Chemical bonds are perhaps the most important aspect of our high school chemistry experience, and therefore it is really important that we understand these basic concepts really well, because later in high school, when these concepts are elaborated on and things get much more complicated, we often find ourselves, very stranded. And so it's really important that we learn these concepts beforehand really well, so that in later years we feel we're able to absorb everything that we learn afterwards. And so today in this video, we're going to look at the two key types of bonding: ionic and covalent. So without further ado, let's just get straight into the first type, ionic bonds. Okay, so before we look at ionic bonds, let's take a look at chemical bonding in its entirety. So first of all, what is a bond? A bond is a force. What type of force? A force that helps combine multiple atoms. And now there are three key types of bonds. First of all, you have ionic bonds, which is what we're going to be looking at right now, followed by covalent bonds. And finally, metallic bonds. Now, in this video, we're going to be looking at only these two and not this one. So keep that in mind. So without further ado, let's just get straight into ionic bond. Okay, so let's get a few key points, and then we'll use that to get like an overarching definition of what an ionic bond is. Okay, so and then this definition you can use in your classes and everything, in your tests. So first of all, let's get to the first key point. An ionic bond is a bond between a metal and a non-metal. So here we said two key things. An ionic bond is a bond between a metal and a non-metal. So let's study this further closely. Okay, let's take a look at metal. And remember, it's always a bond between a metal and a non-metal, nothing else. It can't be a bond between two non-metals, and it can't be a bond between two metals. There has to be one metal and one non-metal. Okay, so let's take a look at metals first. Metals have a tendency to lose electrons. Tendency to lose electrons. And how many electrons do they have in their outer shell? They have 1, 2, or 3 in their electrons in their valence / outer shell. These two mean the same thing. Now, let's take a look at nonmetals. Nonmetals have a tendency to gain electrons. And how many electrons do they have in their outer shell? They have 4, 5, 6, or 7. 4, 5, 6, or 7 electrons in their valence / outer shell. Same thing. And remember, if they have 8 electrons in their outer shell, this basically means that they don't need any more electrons, and therefore they're inert. So that's everything in the noble gases. And so basically, here's the thing, right? What happens is that since there's 1, 2, 3 electrons and this is this shell, and this has 4, 5, 6, 7, what they're all trying to do is get a full outer shell. And so once they have a full outer shell, what's going to happen is that they're going to be stable, and they're not going to look for more electrons. And a bond is basically trying to make substances inert. So let's say 1 electron plus the 7th electron, you get 8 electrons, and that's an outer shell. Or this one reacts with this 6th one, and you get 8 electrons. You're inert. You don't need anything more. And so, let's look at the formation of one of the most common ionic bonds, salt. Formation of NaCl. And we'll use what we've learnt and apply it here and say how sodium chloride is formed. Okay, so now let's look at the electron configuration of sodium. So electron has 2 electrons in its first shell, followed by 8, followed by 1. Now electron wants a full outer shell. Sorry, sodium wants a full outer shell. Now chlorine has 2, 8, and 7. And chlorine wants a full outer shell as well. And sodium is a metal. Chlorine is a non-metal. So what happens here? We said that metals have a tendency to lose electrons because how many electrons do they have in their valence shells? 1, 2, or 3. Is this true? Sodium has 1 electron in its outer shell. That's true. And secondly, it will have a tendency to lose electrons. So what will sodium do? It will give 1 electron to chlorine. And what is chlorine? Chlorine is a nonmetal. What are the rules for nonmetals? They have a tendency to gain electrons because they have 4, 5, 6, or 7 electrons in their outer shell. Does chlorine have any of these? Yes, chlorine has 7 electrons in its outer shell. Okay, so this sodium will give 1 electron to chlorine. Now, we know that in most cases, the amount of electrons is going to be equal to the protons. So how many protons will sodium have? Sodium will have 11 protons. Now, since sodium has given 1 of its electrons to chlorine, what's going to happen is that it's going to have 10 electrons. What happens in this case is that there's more protons than electrons, and so there's a greater positive charge. So sodium becomes positively charged. Let's look at the case of chlorine. Chlorine has 17 protons. If you check its atomic number, it's going to be 17, so it has 17 protons. And it also has 17 electrons. But this 1 electron that sodium gives to chlorine makes it have plus 1 electron. So 2 plus 8 plus 7 plus 1. How many? That's going to be 18 electrons for chlorine. And since there's a greater negative charge, chlorine is going to be negatively charged. So remember, in this case, the non-metal is always negatively charged and the metal is always positively charged. So now I have sodium on its own, positively charged, and chlorine on its own, negatively charged. And one thing that we know about this kind of attraction, first of all, this is electrostatic attraction. This is the kind of attraction where when you rub your head on a balloon and you take pieces of paper and those pieces of paper stick on your head. And so this is the same type of attraction, electrostatic. Now, there's going to be a strong electrostatic attraction because opposites attract, positive charged with a negative charge. And so they're going to attract and they're going to create sodium chloride. And so this is the substance that we get. Positive, negative, they both attract, and so then they become neutral in charge. They become neutral in charge and both of them are inert. So there we go. That's attracted. And since they're both there, they just get attracted. And that's how you get sodium chlorine, okay? Now, another key thing. We talked about this so that was our first point. Now, since we talked about this attraction, let's write a key point on that as well. Point 2 is formed, so ionic bonds are formed through a strong electrostatic force of attraction. Okay, that's it. Third key point. Formed through a cation. What is a cation? A cation is a positively charged atom. So, a positively charged ion, sorry. And so, what was our positively charged ion? The sodium. And so, the positively charged ion is always a metal, formed through a cation, which is the metal, and anion, which is the non-metal. Now, let's summarize what we just looked at. Metal loses an electron, and so it loses a negative charge, so it has more positive charges. Loses electron, and non-metal gains the electron. Okay? Now, when something loses an electron, we call that look at this. This is an important point. When something loses an electron, we call that oxidation. And when something gains an electron, we call that reduction. And in this case, we notice that oxidation and reduction both happened at the same time. And when they both happen at the same time, we have a special term for that, and that is redox. And so this is a redox reaction. So everything that it takes to form an ionic bond is a redox reaction. Okay, so now that we've looked at the key points, let's look at a formal definition. Let's use these key points to come up with a formal definition that you can use in your tests and in your school work. Let's go straight to that. Here we go, a definition. You might want to write this down, and it's a pretty long and very detailed explanation of what an ionic bond is, and has everything that we've learnt. An ionic bond is a bond formed between atoms when an electron is transferred from the valence shell of the metal atom to the valence shell of the non-metals atom, and there is a strong electrostatic force of attraction. And this is basically what we've learnt, is that the metal has a tendency to lose electrons, and so therefore it becomes positively charged, and the non-metal has a tendency to gain electrons, and therefore it becomes negatively charged, and then there's a strong electrostatic force of attraction. And when we talk about electrostatic force of attraction, we're talking about the attraction that we have when we brush our hair against a balloon, and then we attach pieces of paper. Now, since we're looking at this, let's take a look at a few other examples of ionic bonds and how they work. Okay, first of all, magnesium chloride. Okay, let's look at the electron configuration of magnesium. And luckily this time I bought a periodic table with me. So if we find magnesium over here, it's over here, number 12. Now, since we already know the amount of electrons it has in its outer shell, it's +2. Okay, and so this is how you read it. In the first part, you have +1s. So +1, so they have 1 electron in their outer shell. Then you have 2 electrons in your outer shell. You skip all of this. So in the first group, this is referred to as a group when you go down. In the first group, you have 1 electron in your outer shell. Then in the second group, they have 2 electrons in their outer shell, and then you skip all of this, right? And then in the third group, you have 3 electrons in your outer shell. Fourth group, 4 electrons. Fourth group, 4 electrons. And then the fifth group, you have -3, so 3 less than the full shell. Okay, so you need 5 more, so you have 5 electrons in your outer shell, and you need 3 more for a full outer shell. In the sixth group, you need 2 more electrons for a full outer shell. In the seventh one, you need 1 more electron. So another way you can look at this is that since it's -3, you're 3 less than a full outer shell. -2, you're 2 less than a full outer shell. -1, you're 1 less than a full outer shell. And in the last one, you don't need any more electrons. So you're 1 more than an outer shell, you're 2 more than an outer shell, you're 3 more than an outer shell, you're plus or minus. So you need 4 more for a full outer shell, or you need to get rid of 4. So you need 4, or you need to get rid of 4. Then you need 3 more for a full outer shell, you need 2 more for a full outer shell, you need 1 more for a full outer shell. Okay, so what happens is atoms that are in the 1, 2, and 3 have a tendency to lose electrons, and then these ones have a tendency to gain electrons. Okay, so let's look at magnesium. Where's magnesium? Magnesium has 2 electrons in its outer shell. So, and since its atomic number is 12, what we're going to do is that we know in the first shell there's always 2 electrons followed by 8. And so 2 plus 8, 10, and it has 12 electrons. And we already know that 2 must be in its outer shell. Makes sense. 2 plus 8 plus 2. Chlorine. Where's chlorine? Chlorine. Here. So, chlorine, here. Okay. So we know that chlorine is 1 less to a full outer shell. So it has 7 electrons in its outer shell. So 7 electrons in its outer shell. Always 2 in its first shell. And it has 17, so 8. Makes sense. Chlorine again, 2, 8, 7. So which one's the metal? Metals are 1, 2, 3. Metals have a tendency to lose electrons. Okay, so this is the metal, magnesium. Magnesium will have a tendency to lose electrons. And chlorines will have a tendency to gain electrons. So how will this work? Magnesium will give one of its electrons to one chlorine atom, and so now it has 1 electron left. What it's going to do with this leftover electron, it's going to give it to the other chlorine atom, and that is why you need 2 chlorine atoms to make up for that 1 magnesium metal. And so this is how you get magnesium chloride. Now let's look at chloride. Let's look at magnesium oxide. Now, from before, we already know the electron configuration of magnesium. Now let's find the electron configuration of oxygen. Okay, oxygen is 2 less than a full outer shell. So that means it has 6 electrons in its outer shell. Now, okay, let's just do that. 2 always in the first shell and 6. And that equals 8. Is 8 its atomic number? Yes, 2, 6. Now, magnesium, what it does is that since it has a tendency to lose electrons, it will give its 2 electrons to oxygen, and oxygen needs 2 more for a full outer shell. So at the end, magnesium will have an electronic configuration of 2, 8, and oxygen will have an electronic configuration of 2, 8. And since magnesium gave its electron, magnesium will be positively charged and oxygen will be negatively charged. Strong electrostatic force of attraction, you get magnesium oxide. So now that we're done with a few examples and a definition, let's look at some key properties of ionic bonds. So let's go straight there. So it's time for some properties of ionic bonds. So first, let's look at the first and most important property. And this property defines pretty much all of the other properties. They have a very strong electrostatic force of attraction. So what does that mean? We say that it's positive, it's negative. You have the metal that's positive and you have the non-metal that's negative, and then they're very strongly attracted. And so this is very strong. They're very close. So it's not, you know, when you rub your hair on a balloon and then put pieces of paper and how it sticks for some time and then it goes away. That's not the case over here. It's very strong. They're very close, that they never lose actually. They never actually fall apart. Okay? And so since they have a very strong electrostatic force of attraction, so the ions are so closely packed together that their general state is a solid. Their physical state is generally a solid. And why is it a solid? Because we said that their electrostatic force of attraction is very high. And when your electrostatic force of attraction is very high, what tends to happen is that you become super closely packed. And so if we look at the example of sodium chloride, sodium and chloride are very closely packed. And so what happens is that when they're really closely packed, the atoms are very close. And when the atoms are very close, you have a solid. Okay? And that's why when you take a grain of salt, it's solid and it's not melted. And so they have a high, and this is why, and since they also have a high strong electrostatic force of attraction, another property, which is going to be our third property, is that they have a high melting and boiling point. High melting and high boiling point. There we go. Now fourth, they're soluble in water. That means they dissolve in water. If we take the example of salt. Salt is soluble in water. If when you mix salt and water, the salt disappears, right? Another thing is hydrochloric acid. When you have hydrochloric acid, sorry, not hydrochloric acid, yeah, anyways, not hydrochloric acid, sorry, don't write that down. Anyway, salt is soluble in water. That's an example. And next one is that they're insoluble in organic solvents. So they're insoluble in organic solvents. And organic is anything that contains carbon. So they're insoluble in organic solvents. Insoluble. Yes. So let's look at the full 5 key properties again, and then we'll move on to the 6th one. They have a very strong electrostatic force of attraction. Their physical state is generally a solid. They have a high melting point and a high boiling point. And because that is why their physical state is generally a solid. And they're soluble in water. And our prime example is sodium chloride, not hydrochloric acid. I said that by mistake, so get rid of that. Don't think about that. Okay, and our 5th one is they're insoluble in organic solvents. So this is anything that contains carbon, and a solvent is something that something else dissolves in. So if I have, if I mix sodium and sodium chloride and chloride in water, the water is the solvent. So this is the main substance that this is going to get dissolved into. This is the solute, and this is the solvent. Okay, now let's move on to the most key and most in-depth property of ionic bonds. It is that they conduct electricity. They conduct electricity in molten state or aqueous state, but not in solid state. And so let's take a look at this closer. When we talk about molten state, we're talking about when it's melted to be a liquid. And this is usually at high temperatures because they have a high melting point. Remember? And they also conduct in aqueous state. So this is when they're dissolved in water. Remember, they're soluble in water. Okay, so let's take a closer look at this. So, in their solid state, ions are not free to move. So when they're in their solid state, the ions are so closely packed together that they're not free to move. And therefore, but in their molten state, so in their liquid state, sodium chloride ions are free and are able to conduct electricity. Because when you look at solid and when you compare that to liquid, what happens in liquid is that the ions can go over the top of each other, just like how atoms do. So this is going on top of that, this is going, and they're pretty free. Okay, and then a last thing, in aqueous state, they're also soluble. They also conduct electricity. Why is this? Because water has something called dielectric property. We don't need to look at this in too much detail, but water has dielectric property, which weakens the electrostatic force. So, when they're so closely packed together and you put water on them, what happens is that they go a little further away enough so that they can use to conduct electricity. So, in liquid, the ions are free to move over each other, which allows them to conduct electricity. And in water, the dielectric property of water allows them to conduct electricity. But in the solid state, they're so closely packed that they can't conduct electricity. So these are the properties of ionic bonds. Now, let's take a look at covalent bonds. Okay, so let's take a look at covalent bonds. What we will do is that we will look at all the key points, then we'll form a definition, and then we'll look at a few examples and their properties. So let's get straight into it. Okay, first key point. It's a bond between non-metals. Now, when we looked at ionic bonds, we said an ionic bond is a bond between a metal and a non-metal. And so you only had two different atoms. But that's not the case with covalent bonds. You can have two different atoms, you can have three different atoms, you can have four different atoms. Depends on what you're making. So for example, when you're making water, which is H2O, you're only using two different atoms. However, when you're making glucose, C6, carbon 6, hydrogen 12, oxygen 6, you need three different atoms. So it depends on what you're making. So it's a bond between nonmetals. Secondly, it's made by mutual sharing of electrons. Mutual sharing of electrons. So I think we've all heard that in covalent bonds you share electrons, but the key thing here is mutual sharing, mutual. So here you only get the amount of electrons you share. You only get the amount of electrons you share. So if a hydrogen atom shares one electron, it only gets one electron in return. Okay, remember that. So let's take a look at a few examples. A hydrogen. So a hydrogen has one atom in total and therefore one atom in its outer shell, and for it to be stable it needs two atoms in its outer shell. So what happens here is that they decide to share, and so what happens is that this atom moves in a infinity symbol kind of path, and so does this atom. And so since both of them now both of the atoms visit both of these nuclei, what tends to happen is that now you can say that, oh look, this has two electrons and so does this have two electrons, and so therefore they're both stable. Let me draw a better diagram. It's hydrogen, this is the nucleus, these are the electrons. What tends to happen is that they go in this kind of formation. So both of them have two. Okay? Now, this is a single covalent bond. Hydrogen, that you're only sharing one electron. Each atom only shares one electron. Now, when each atom only shares two electrons, you get something called a double covalent bond. Let's look at an example. Let's take oxygen. Oxygen has 6 electrons in its outer shell. Six electrons. And so, each of these need two more. Now, what happens is that they share 2 electrons. So now at any time you can say that, oh look, this has 8. Oh look, this has 8, so both of them are stable. That's your double covalent bond because you're sharing 2 electrons each. Now, finally, you have triple covalent bond, where you share 3 electrons each. So, nitrogen has 5 electrons in its outer shell. And so what happens is that they share these electrons. So at any given time, this has 8. So does this. Triple covalent bond because you're sharing 3 electrons. Now let's take a closer look. Since this is a single covalent bond, remember there's still 2 nuclei. There's still 2 atoms in total. So I'd write this as H2. Similarly in here, there's only 2 atoms in total. So this would be O2. 2 nitrogen atoms in total, N2. So now, okay, and third key point, final key point. They create molecules, not ions. When you share electrons, you get molecules. But when you give electrons, you get ions because they get charged. But now you're just giving them, so you're creating molecules. So this is a nitrogen molecule. This is a hydrogen molecule, blah blah, oxygen molecule. But look at another key thing is that you get molecules, not ions, right? But remember, both molecules and both ions, when you create an ion with 2 different atoms, and when you create a molecule with 2 or more different atoms, you get a compound. So remember, it has to be 2 different or 2 or more different. In the case of ions, it's 2 different. In the case of molecules, it's 2 or more different. So these are the key points when it comes to the properties of covalent bonds. Now let's come up with a definition of covalent bonds used based on this that we can use in our exams. Okay, so the definition of a covalent bond. A covalent bond is a bond formed between two or more non-metals through the mutual sharing of electrons. Let's look at an example. Carbon dioxide. So, 2 oxygen atoms and 1 carbon atom. 1 carbon, 2 oxygen. Okay? Now, how many electrons does a carbon have in its outer shell? As we can see over here, carbon has 4 electrons in its outer shell. And we have oxygen. Oxygen has 6 electrons in its outer shell. So, 4 and 6. Now, oxygen needs 2 more electrons and carbon needs 4 more electrons. So what they do is that they share. So what I would do is that we draw a line like this. So now, at any given moment, carbon has these 2 plus these 2, so 4, and then there's 2 that it shares with each of its oxygens, so 8. So 4 that it already has, plus 2 electrons that it gets from one oxygen, and another 2 electrons that it gets from the other oxygen. So 8 electrons in its outer shell. Similarly, oxygen has 6 electrons, so it needs 2 more. This part of carbon gives it those 2 extra electrons. So 6 plus 2 equals 8. That's the same with here. This has 6 electrons, needs 2 more. This part of carbon gives it 2 more electrons. 6 plus 2, 8. And so everyone is happy. Everyone has a full outer shell. Now, let's look at some properties. The first property is that they're bad conductors of electricity. So basically, a covalent bond is everything opposite. Most of a covalent bond is opposite of ionic bonds. They have a weak van der Waals force. And we'll take a look at this in a bit after we look at the other 3. They exist as gases, liquids, or soft solids. So the atoms are not very closely connected. And so since they're not closely connected, they don't exist as, solids like ionic bonds do. Okay, next. They are generally insoluble in water. So they don't dissolve. And finally, they have low melting and low boiling points. See, the opposite of ionic bonds. And why is this? It's because the nature of covalent bonds are not as strong as ionic bonds. And remember, there is no electrostatic force of attraction in this because there's no positive and negative charge. There's only sharing of electrons. So no electrostatic force of attraction over here. Okay, so let's take a look at this van der Waals force. So now that we've looked at everything, let's take a look at van der Waals forces. So imagine you have a water molecule, H2O. Now, what happens is that you think that everyone has a full outer shell, so they're all going to be happy, right? And yeah, that makes sense. But let me just quickly draw another water molecule. What tends to happen is that this oxygen and this hydrogen are, very weakly attracted. Not so strong, they're pretty weakly attracted. And similarly, if I have another water atom, so something like this is also going to be very weakly attracted. And so van der Waals forces are this force of attraction that occur between molecules. So you could call this an intermolecule force of attraction. Intermolecular force. And covalent bonds have a very weak intermolecular force of attraction. So you may although these are attracted, it's very weak, very, very weak. If you search up van der Waals forces for water, you'd get something like this. And you can see that although everyone has a full outer shell, and they're all happy, there's still some attraction, but we don't need to worry about this too much just yet. We'll look at this, later in some other video. But yeah, this is the definition, example, and properties of covalent bonds. So that was pretty much it for this part. Okay, so that was it for this video. And so I hope that you've learned something and you've, got those concepts of ionic and covalent bonds really rooted in your understanding. I do recommend checking out some other videos for some better examples and more complex examples, depending on where you're at in your learning. So if you're in the lower grades, I think it's fine, but if you're in the higher grades, I do recommend that you look at those videos. And yeah, that was it for this video. This is the second part of the series, of the chemistry series. So if you're interested in the first part, the first video, we talked about the history of the atom and how the atom evolved. So yeah, I hope you enjoyed this video and I hope you learned something. I'll see you in the next one. Till then, keep grinding. Bye bye.